I'm Varun. So today I'll be taking you through OpenSearch's journey to being a cost-optimized engine. I'm a senior SDE at Amazon, and I've been contributing to OpenSearch since last almost 3 years. I mostly work with the storage team in India. Okay, let's get started. So on today's agenda, we will be talking about the conventional replication model that OpenSearch used to operate on, which is a document replication model. Then we'll talk about what are the problems with the document replication model, and we'll talk about then segment replication, how we introduced it, how it works. We'll talk about various benefits that were added with segment replication, and we will talk about some not so obvious benefits that you might not be aware about segment replication. And in the end, I'll close with some recommendations on, if you want to go and migrate from document replication to segment replication, what things you need to be careful about and what you need to monitor for. So let's start with the basics. So in any distributed system, the concept of replication exists to introduce durability. That is one of the use cases of introducing replication in your distributed system. Now, let's say you have a copy of a data in your distributed system. You add 2 more copies so that when one of the copies goes down, the other 2 are available to keep your replication up. Now, OpenSearch is built on similar primitives. OpenSearch also supports replication. And if you create a shard, you can define the replicas. Here I have defined 2 replicas. So in total, there are 3 shard copies in your OpenSearch cluster for a particular shard. Now the problem with this approach is that whenever you send a document to index to OpenSearch, it goes to the primary shard, and primary shard will index it. But that's not all OpenSearch does. OpenSearch will also send the same document to the replicas. Replica will perform all the same indexing on all the same indexing that was done by the primary. So you are doing the same duplicate work, redundant work on all the replicas that you have configured. Now, it seems pretty obvious that you are paying for the same amount of work n+1 times, where n is your number of replicas, and you are wasting a lot of CPU, memory, and I/O in doing so. This is how the traditional document replication model worked. Now, we introduced segment replication in OpenSearch some time back, and segment replication basically says that I will not pay for all that extra compute. I will only index the document once on the primary, and my replicas can get that segments from the primary. So this way we save all the extra compute that we were spending on the replicas, and all the I/O that we were spending on the replicas, and you spend it once only on the primary. Apart from segment replication, there is one important thing here to notice is the use of remote store. Now, segment replication in conjunction with remote store makes OpenSearch really powerful and runs it in a really efficient way. Now, what happens here is that primary receives the indexing request, and it will create all the segments. Those segments will be sent to a remote store. A remote store could be any blob store, like Amazon S3, Google Cloud Storage, right? Anything of your choosing. And replicas will connect to that remote store and download the segments. So no node-to-node communication now. Only the replication checkpoint information is sent from primary to all the replicas, and the download of the actual segments is happening from the remote store. Your primary is freed up now. You are not doing any duplicate work. So you're only paying once on the primary. So we have eliminated the redundant CPU and everything, right, on the replicas. So all that extra compute or resources that were there in the cluster that were previously consumed by the replicas are now free. Now, it's up to you to cut the cost, or you want to utilize it for more indexing, so you can do that. This should, if not 50%, it should give you, it should run your OpenSearch cluster at 2/3 of the cost. Okay, now, these were some of the obvious benefits with segment replication. But now, with remote store, you get some additional benefits. You get added durability for your data. So earlier, all the data was on the cluster nodes. Now, instead of cluster nodes, your data is backed up on remote store, which the common remote stores out there like Amazon S3 or Google Cloud Storage, they offer 11 lines of durability. That was unheard of for OpenSearch like engines before. Also, you get faster and safer recoveries because now your replicas or any shard copy is recovering from remote store and not from any node in the cluster. So, your cluster is pretty independent from the recoveries that are happening. And these are faster as well because the downloads from the remote store will be fast than any node-to-node copy that was happening previously. We'll talk more about recoveries. I have an example. And you get faster snapshots as well. So if you are aware about the snapshot feature in OpenSearch, snapshots are basically point-in-time captures of your data that are uploaded to remote store at a periodic interval. So, with already OpenSearch uploading your data to remote store as part of indexing, you don't need snapshots to do that. Let's understand about how recoveries are made fast with a simple example. So let's say you have a 2-node OpenSearch cluster with 1 primary and 1 replica setup, and you have set up it as a segment replication and remote store cluster. So what happens when one of the primaries goes down? Your other replica will be promoted to primary on the other node. So here, the other replica will download anything that it was lagging behind from the remote store. Remember, we are not sending the requests to the replica. We are only indexing on primary and uploading to remote store. So your replica might be lagging behind on some of the segments and translogs. So it will download it. It will replay them, and it will be ready to serve the traffic. Now, here, there is not much gain compared to document replication, because in document replication, it might perform better because, your replica was already caught up because we were sending those documents to replicas. But where segment replication will really shine is that, when new node comes up and you have to recover the new replica due to the earlier node failure, the entire data needs to be sent to that new node. Now, this is where segment replication and remote store really shines. Now you will not disturb your node B's primary, and you will just download the data from remote store. This way, your primary on your node B is left untouched, and it is not bothered with what is happening with the replica recovery, and replica can independently recover from remote store. This is very safe than, in a traditional OpenSearch cluster when you do node-to-node copy in such scenarios. That way you, tap into the I/O bandwidth of the primary on node B. Now the recoveries will be faster as well, obviously, because you are downloading from a remote store, not from a node that is in the cluster. Okay, let's quickly talk about snapshots as well. So snapshots, I told you earlier that they in document replication model they would capture point-in-time states and they will upload them to remote store. But with segment replication model and remote store, you are already doing that. So snapshots can be as simple as just uploading a simple log file in your remote store, which will tell that I, as a snapshot, want to lock these segment files that are already present in the remote store. And our garbage collection flow, which was responsible for clearing old data from remote store, will see that these log files are present, and I don't have to clean up these files. So these snapshots become pretty seamless now, and they are pretty fast because you're not uploading the data as you were doing with document replication. You are just uploading one log file per shard in the snapshot. So, everything looks pretty good, but what did we trade off, right? Nothing comes free in this world, right? So you had a pretty awesome segment replication model, and you saved cost, but there are some gotchas that you need to be aware about before making a decision, to use segment replication. Now, one of the major things that we have found out that users saw lacking in segment replication was the read after write latency. So if you see the difference between document replication, where real time we were indexing the documents on all the replicas, here the replicas are getting the documents through remote store. So there is a round trip involved where primary is uploading the documents and replicas are downloading them, right? So this latency will cause the documents or the document that you have indexed on primary to show up on the replica a little later than it was doing on document replication. So for folks who have, who have very critical search workloads and, they want very real-time search performance, very real-time performance for read after write latency, this model might not work because of the added latency in the round trip. That is something that really need to think about before, we run behind the cost benefits for segment replication. Then there is primary shard balancing. So we'll talk more about primary shard balancing in an example, but as an overview, now compared to document replication, where all your shard copies, replicas and primaries were doing the same amount of work, here your primary is the only one doing the excessive amount of work. Replicas are pretty dumb, they are just downloading the data, right? So your balancing approaches in OpenSearch needs to be aware that, my replicas won't be consuming that much resource compared to primaries. So I need to distribute primaries evenly across the nodes, right? Whereas in document replication, every shard copy, primary or replica was same for the balancing that OpenSearch did. Then you have the added dependency on a new storage system, like it could be Amazon S3, Google Cloud Storage, any blob store out there, right? So you need to be aware about their SLAs around durability. Various, I think most of the very famous blob stores out there offer 11 nines of durability. I don't think you should settle for anything less, but please, when you choose a blob store, do take a look at their durability guarantees. And then availability, scalability, obviously, your remote store needs to scale, right? If your remote store is not able to handle the writes and reads that the OpenSearch cluster is doing, then your cluster will be unhealthy or your data will not be available. Now your storage system needs to be available, right? If your storage system is not available, your data is not available, right? And your writes will fail and all that, right? Your cluster will be unhealthy and your application will suffer. Then finally, you need to be aware about the response times for various requests, like get, put, delete. These are the common requests that are done in the remote store interaction through OpenSearch. And if any of the remote store that you're going with, please do compare it with the industry standards. And if they are offering higher latency, please remember this will impact your overall indexing latency as well, and might also worsen the read after write latency. Now I'll quickly explain the primary shard balancing problem with an example. So let's assume that you had a document replication setup with 3 nodes, 3 primaries, each primary had 1 replica. Now it could very well happen that in document replication world, OpenSearch would assign the shard something like this, where node A has 2 primaries, node B has 1, and C doesn't have any primary because it is having 2 replicas. This will work perfectly fine in document replication world because all the shard copies are using the same amount of resources. But when you move to segment replication world, right, if you do balancing like this, your node A will be doing most of the work and node C will be sitting idle. So you will see a skew in the resource utilization across your nodes. So we don't want that, which is why we introduced a new balancing approach, which first caters to primaries and evenly distributes the primaries, and then it will cater to the replicas, and replicas will be evenly distributed in the remaining slots. So this way, we have ensured that primaries are evenly distributed, and your workload in segment replication with remote store is also evenly distributed across all the nodes. Okay. Yeah, this is another important consideration. Not a huge one, but you should be aware about it. So when you are indexing in document replication world, there is a concept called translog, and when the writes happen, the segments are generated later during a refresh, a background task. But to make your data durable, what OpenSearch does is that it will write that document to a write-ahead log, which is translog in this case. Now, when you are operating in document replication world, this translog was just a file on the local disk, and you could just do a append operation that is quick. And for each request that was coming in, you could independently do that operation instantly. Once that is done, you could acknowledge back to the user that your indexing is complete. But when we move to segment replication with remote store, translog also has to be sent to remote store, because translog also needs to be made durable to fulfill the durability guarantee, request level durability guarantee for a user. Now, if you keep uploading for each request that comes to a remote store like S3, your latencies will spike up, indexing latencies will spike up. So to control that, we added a new buffer, which is the translog buffer. This comes in the segment replication world with remote store, where a request, so all the requests that are coming in that interval, in that buffer interval, which is, let's say, 600 milliseconds, will be pooled together to be uploaded to remote store. This way you will save the cost, and you will batch a bunch of requests when doing a remote store upload. Now, this is adding a static waiting on the requests, because this has to be blocking. Until you have made your translog durable in the remote store, you cannot acknowledge back to the user saying that, I have successfully indexed your document. So this is the amount of time that your request might wait. You can even reduce this interval from 600 milliseconds to, let's say, 200 or 250, and play around with it. This is a cluster setting, but this is blocking. So this will cause your request to block. It won't be doing anything. It will just be waiting for upload to happen. Now, to get over this, we recommend that you either make your requests, bulk requests, very large, so that a lot of data is present in one request, or you you increase the number of clients that are sending the requests. So if you see some benchmark results here, you will see that with the 8 clients in the OpenSearch benchmark tool, we were able to get these numbers: document replication at 28K, segment replication at 40K. Approximately 40% improvement in the indexing throughput without changing anything in the cluster's resources. Now, if you see how we move towards having more number of clients, you see that the document replication performance stagnates, because it doesn't matter how many clients you increase for document replication, it's already maxed out. But you see that segment replication with remote store really shines here. When you send more requests parallelly, the batches can be bigger in the translog uploads, and you will get a better performance. And you can see even you can get up to 60% performance improvements with segment replication at remote store if you configure your number of clients correctly. Okay, now let's talk about some safety mechanisms. So we have introduced back pressure as well for segment replication as well as remote store separately, which monitor the important metrics and will reject your requests, a user's requests to the cluster if they are seeing a problem with the remote store or any other problem where your cluster is not performing well. So the main intention of introducing this back pressure is to not keep accepting users' requests because your cluster is not behaving in a healthy shape. Some of the key metrics that we use, or even as an operator you should be monitoring, replication lag and remote upload time. This is something that is used by back pressure as well to monitor the state of how segment replication is performing, how your remote store is performing. These are the metrics that you should be really careful about. These replication lag directly indicates that how far behind your replicas are lagging from the primaries. Because of the round trip that we are doing, we are first uploading, then we're downloading on the replicas. Remote upload lag, this is basically the lag between your primaries generating new segments during refreshes and uploading them to remote store. So the lag between that time. first segment when the segment first appears locally and when it appears in the remote store. Now when we first developed this and we were playing around with it, we also encountered a lot of throttling from the remote store that we were using, where we had to work around to resolve those issues. So please be watchful of that. If you are running very heavy indexing workloads, you might run into these problems, and you might have to understand more about the remote store that you're using and how to optimize or how to get better performance out of the remote store. Then again, please do run very rigorous performance tests before you plan on tapping into these cost benefits and adopting segment replication. This will definitely save you cost, but please be careful when you migrate. Do run all the performance tests, right, and make sure that you're not regressing or you need some tuning in any of the parameters like buffer interval we talked about for translog. Okay, so few other things I want to touch upon, which you should definitely go back and read on, which are a complement or a alternative to some of the things that we talked about here. One is remote cluster state. So remote cluster state is basically like a remote store is for your data. Then your cluster state also is uploaded to remote store as part of remote cluster state. So this not just only protects your data, it also protects your cluster state. And this comes in handy when if all the all the cluster manager nodes in a cluster are gone and your cluster state is lost, you can basically recover it from the remote store. So this gives you that peace of mind. This also, recently we have introduced remote publication. This basically eliminates the overhead on the active cluster manager node to broadcast to every node in the cluster what is the current cluster state. And with remote publication, each node can basically pull that data from remote store because remote store now has it. Next, if you do decide to move to segment replication after running all the performance tests, we have natively support of migrating to segment replication from document replication in an existing cluster. Then there is searchable snapshots. Searchable snapshots are a little different and an alternative of how remote store works, and it might also serve your use case. I'll share the links. Please do read upon it before you make a decision whether you want to use segment replication. Then with introducing segment replication with remote store, we have also, it opens up some new possibilities which are currently being worked upon, like reader-writer separation. Here you can separate out your readers from your writers. So indexing happens on a different node and your searchers can sit on a different node. This way you can get a very predictable performance out of, your shards, which are doing just one thing. This is something that is enabled with segment replication and remote store. Then again, you have decoupled your storage from your compute. Earlier, your data was sitting all on the nodes along with the shards. Now your data is sitting separately in a remote store. So you have introduced a shared storage kind of concept where all your shard copies sitting on the computes will be reading from that shared storage, right? And we haven't fully tapped into the benefits of shared storage, but this is something that is enabled by introducing segment replication with remote store. And this will in future, I'm hoping the community evolves around it, and you can really benefit from shared storage to have very fast scaling. If let's say you want to scale very fast for your search traffic and all, right, shared storage can really help there. But these are some of the future things that we will be able to build after segment replication and with remote store has been introduced in the cluster. These are some of the important links, some very basic links to start with, to start reading upon, to get more insights into what is segment replication, what is remote store, what is searchable snapshot. I will upload the slides or the deck later today, so you can refer to these links. Okay, that's all. Thank you.